So let me introduce the Cinthia Antunes, Correa. Okay. So she got a master degree in the Federal University of Goiás in Brazil, and then a PhD in the Charles University, Czech Republic. So she has been since then she has been working on the electron diffraction and single crystal and powder XRD and TEM, and basically on the material and also especially the modulated system. And then she is a specialist in dealing with JANA. And now she is working at the Institute of Physics of Czech Academy of Science. Okay.
Thank you very much for the introduction. Yeah. Well, I'm not the developer of JANA. It's Václav Petříček here. Unfortunately, he could not come, so I will show you today JANA. Maybe before I start, I'd like to ask how many of you have ever heard of JANA or knew what JANA was before the workshop, before the organizers told you to install it? Okay, good. That's good. So for the very few of you who used JANA before, I believe you have tried maybe JANA 2006. So for those who tried already JANA 2020, I am sorry, I will apologize, but I will start from the very beginning. For those who have never seen it before, yeah? So before that, I would also like to thank the organizers for letting me come instead of Václav. So this is the Institute of Physics, where JANA is developed. Actually, last year, the building celebrated 100 years, and as you can see here, it looks like pretty much the same. The only difference is maybe the bicycle here. And since 1980s, JANA has been developed in the office behind this window by Václav Petříček. He started working at the Institute of Physics in 1971, and pretty much like Cavarral and other colleagues here developing softwares, he was interested in materials, and he needed some tool to analyze the structures. So he started initially with a program for solution and refinement of 3D structures called SDS. And then in 1984, during his stay at Philip Koopman's lab, he started writing JANA in a close collaboration with Becker. Since then, several other people started also working on the analysis of crystal structures, and JANA has then been developed a lot. It has a graphical interface now, and from the version 2006 to 2020, which was actually published in 2021, we also have JANA Draw, which is much more user-friendly, and it helps quite a lot with the analysis. The collaboration is, of course, with everybody who works in our department, but it's also with the users, because every time users report an error or a bug, JANA improves a bit. Since I'm not a developer, as a user, I tend to see all these softwares as tools. So we have a big toolbox with several softwares that you have seen here during this week. And JANA is one more tool for your work. So some of you might be interested in programming and such. I will show here the, let's say, easier version. For those who would be more interested in more details, I can give you references later. Yeah? What can JANA do then? We can work with different types of compounds or structures, materials, oxides, organics, zeolites, all sorts of materials. We can handle different types of data, so from single crystal, from powder, from nanocrystals. We can also use different radiation sources. It can be X-ray from your home lab, it can be synchrotron radiation, neutrons, electrons, and with all this we can model different types of structures. So it can be a modulated structure, a simple structure, disordered, composites, and so on. It can cover then, from basic crystallography for simple structures, we can cover from small molecules, a small part of it, more complicated structures, disordered twinned, as I mentioned, aperiodic structures, magnetic structures from micro and nano crystals, and a bit of proteins. What we cannot do, we cannot handle, it's big proteins that we can't do. How to get it and where to get JANA. So if you just Google JANA 2006 or JANA 2020, it will send you to this website, and from here you can find links to register, download, install JANA. If you click here to download the last version, this link will send you to a registration page where you can register yourself, and once you have your registration, you can download, install the software, and then you also have access to the cookbook. The cookbook, it's a compilation of problems that we have been working on, and it's examples. You have the examples on how to do things in the software, and for all sorts of structures that we worked on. So you can find it there from simple single crystal X-ray data up to the magnetic ones. For those who have never worked, it's very, very helpful because we updated these examples very often. So you have here also when it's updated. You can filter here the examples by topic or by difficulty or just by number, and then you can see what have changed or the last updates of the software. In the website, you can also see some information about the workshops. JANA has several workshops in a year. So for those interested, you would just need to send an email to Michal Duszek, and he will add you to the list of participants of the workshop. The workshop is for free, it's free, so whoever would be interested to participate would just need to cover his or her travel expenses. Once you have downloaded the software, it will come with it Superflip for structure solution. You also have Dingo, which is for performing the dynamical refinement on electron diffraction data, Marching Cube, which is for seeing isosurfaces, and you can also run directly from JANA plotting programs such as Diamond and Vesta that you have been used this week. Also other programs for structure solution like Shelixty, server. You can also access directly from JANA the Bilbao server and the ISO distort. And for magnetic structures, you actually use it interactively. How does JANA look like? This is the newest version, JANA 2020. So you can see here the main window. On the left side here, you have the left pane, here the right pane. On the right pane, you have some application controls for the image, how to see it. Here, down here on the left pane, you have the refinement window that shows you the results of the refinement. And on JANA Draw here, you can change some settings here for the image or add new atoms or filter some atoms. Also from JANA Draw here, you can directly click on the atoms you'd like to modify. So you can modify parameters for some atoms. Here on the right side you have, I'm not sure you can see it, but it's a basic window. So if you have the basic mode, you can modify atomic parameters. But if you have here the refinement mode, then you can, by selecting the parameters on the image, you can also modify the refinement parameters for the selected atoms or bonds and so on. If you expand here, on the left pane, you also have command tree, the focus buttons, and the quick buttons, and the main menu bar. So the main menu bar, you can see in which folder you are working on. You can also start new structures or make some transformations, modify settings, use some tools, and so on. And these quick buttons, they are just shortcuts for what you have here in the command tree. And it's the ones that we use the most, so that's why they are here. But if you can also have more options in the command tree, if you expand one of these options here. So for instance, if you expand this reflection file, you can see the options for it. So you have import, run, in silence mode, make space group test, create refinement reflection, and so on. So you have more detailed options when expanding the command tree. Okay, so now let's say you have already the program installed and you know more or less how it looks like. So how does it go? What's the flow of the program? Here we start by selecting the reflection file type. And we can select files from powder data, from single crystal, or from another source. So for the case of magnetic structures, that's we usually use here from SIF, and then you import the data from neutron diffraction, right? So then you select which radiation source you have there, and here you can use, as I said, either X-ray, neutrons, or electrons. You can also combine them. If you have different data, you can combine them all and use it at once. Then we go through the data import, where JANA saves the data repository. Then, using this data repository here, you can use the symmetry wizard to define the symmetry, the space group. Then we go for the structure solution. Once you have the initial solution of your structure, you can plot the image, calculate Fourier maps, perform some modifications or transformations in your structure, also some geometry calculations, and then you can refine. And this part here, it's very interactive. So we change things, refine, change, refine again. And once you finish and you have your final model, you create the CIF file. We will go through each of these steps in more details. And in each of these steps, JANA creates a file here. You have the list here. So for those of you who would prefer to modify things on these files, I can give you the list of files created and what type of information you have in them. But here I will do everything on the graphical interface. It's much easier and it's very simple. Well, and then it's up to you to decide which one you'd prefer to do. It's a very personal choice. So, once you read one or more data sets, JANA will create M50 and M95, and then it will use these files to run the symmetry wizard, solution, and refinement. And starting with the data import wizard, we select in which instrument you measure your data, so which type of file you have. You see that here we have a list of instruments used. If the instrument that you use is not in the list, it's possible to send Václav Petříček information about the instrument, and he can add the instrument to this list. Yes, the presentation is available online, so you will have it later. I think you have it already. Yes, so you. Okay. Then, once we import this data, JANA will read from the input file your experimental information. So it will read the unit cell used for the experiment, wavelength, and such. If the information is not in the input file and you want to change something manually, you can also change it here. So you can change, let's say, the temperature, for instance, if this information was not in the file. Once you are importing the data, JANA will ask you if you want to do the absorption correction or scaling if you haven't done it during the data reduction after your measurement, so you can also do it here. And then JANA saves it in this M95, and this file will be used for future modifications so that your data will not be modified, the original data. So once you have the data, we will go to the symmetry wizard. And all this part was, yes, if you have a single crystal, for instance, but here if you have a powder data, you will want to first run the labile refinement on it, so you can have the profile fitted. And JANA can use either the Gaussian, Lorentzian, or pseudo-void shapes, or modify the Lorentzian as well for the profile fitting. You can also use electron diffraction. In this case, you will have also a file with HKL indices and intensities. And then in the case of electron diffraction, you will need Dingo to treat the data. But Dingo comes with JANA. And the Dingo we use for the dynamical refinement, because then you take into account the dynamical scattering theory. Then, we have now the data, and we go through the symmetry determination. So, JANA accepts for the symmetry any reasonable setting of space group, including non-standard ones, centering ones. It considers, or it runs the systematic extinctions and the symmetry restrictions analytically, based on the symmetry operations and on the actual atomic positions of your structure. It supports an interactive transformation to lower symmetry, so group-subgroup transformations. You can also apply local symmetry to a group of atoms and define rigid bodies. And we also have the superspace approach implemented for 3 plus D with D up to 3 for modulated systems. And when you are running the symmetry or each of these steps, you don't need to start from the scratch if you want to repeat one of those steps. You can always go to that command tree and start it from there somewhere. So for instance, JANA tells you in some of these information windows during the process that you can just go back and run the symmetry wizard directly from reflection file, make symmetry group test. So you also have these information windows from time to time telling you what is coming next, or what you have just done or finished, or confirming something that you did. Once you start with the symmetry wizard, you might want to set here tolerances for the crystal system recognition or also for extinctions. So for X-ray and the neutrons, usually don't need this, but for electron diffraction, we in general increase this quite a lot. Then JANA brings you to the point group selection, and it shows you here the list of point groups available for your system. And then also here, you can see in these details, you can see which reflections, yes, here you can see which reflections here you have there that violate this selection of point groups. So you can decide by yourself in more difficult cases. Then we go for the centering, and it's the same. If you click here, it shows here how many observed reflections you have that should be extinct. And for each of the, well, in this case I don't have here, but if you do have for each of these observe the reflections, you can also check here in details how strong these reflections are. And in more complicated cases, you can also decide if you have some very few reflections and you are not sure, you can decide based on the information you have here in details. Once you have the center in the point group, you can go for the space group selection, and once again, you can check it in details here, some reflections, more problematic reflections. When we finish this part, you can either accept your original unit cell, or you can transform it to the standard settings. And JANA shows you here the matrix, the transformation matrix. Also, if you believe you have twins generated by symmetry, JANA, you have an option slightly before that you could include a twin to your data, and then JANA can create here matrices and save these matrices for twins for the space group test as well. Okay, so then you import your data. You can either average the intensities, or for time of flight, you can use non-average data. And then it shows you here the internal R value for this space group. And based on these results here, you can already, if you are satisfied with it, it's fine. You continue, otherwise you can go back and run the space group test again. Once you have the symmetry, the space group, you go to the structure solution, and then JANA will create M40 with the model, and M41 in case you have a powder data, so it has the information on the profile parameters. For the solution, we have Superflip, comes with JANA, but we can also add other programs here. This is a matter of choice. So JANA can communicate with them as well. And then once you have the solution, we can already go for the plotting or calculate some Fourier maps to see some difference Fourier as well to solve your structure, or do some modifications, some transformations, and so on. And then we go for the refinement. For the refinement, you have many, many options. I will show you here a few of them. So you have, yes, if you open here structure solution parameters, you can modify some atomic parameters. You can refine the scale. Yes, the scale parameters. You can refine extinction parameters, twin, fractions, and so on. And if you click on each of these options, it will open a new window, and then you can select which model or which option you want to refine. For the extinction here, we have different models here for the extinction, so you can also choose or test which one fits better your data, and change it and refine again. For the refinement itself, we have here automatic refinement keys and automatic symmetry restrictions. You can also choose to refine either on F or F square. And if you have these automatic refinement keys enabled, it means that for the refinement, several the parameters will be blocked to the refinement. So it will be refining, and you cannot modify it. If you don't want, like this, if you want to modify it by yourself, then you need to know what you are doing, and you need to select which parameters you want to modify, to refine. Then you just disable this option, and then you can change all the parameters as you wish. Each parameter, or each refinement parameter, each parameter has a refinement key, and also has a unique name. So it means that in the refinement commands, you can change here, you can add constraints and restraints, depending on what you need. So for instance, here you can use, you can define some reflections that should be used or not used, some conditions for indices HKL. You can also use here keep commands and keep some geometry or ADF for different atoms to be the same and so on. For more advanced options, you can also add equations. So you can use these unique names for the parameters to be refined, and you can include linear equations here. So the atomic positions of some specific atom that should be equal to another one, or the occupancy of some molecule, and so on. In the case of powder diffraction, you can also do a fundamental approach, meaning that you set the instrument parameters so that one can separate the instrumental contribution, and then you can have parameters from your sample. So for instance, if you do the fundamental approach, you can calculate here the strain broadening on the peak. You can also have a particle broadening. You can calculate the particle size and so on. Once you have the refinement solution and such, you can also run Fourier maps. JANA uses these files for the refinement, then it generates the M80. It calculates the Fourier maps and saves in M81. And then from these Fourier maps, you can use a contour to see the maps. You can either have a predefined sections of the Fourier map, or you can calculate whichever general section you need. When you are solving your structure, when you're finishing, you can also calculate the difference Fourier to see if you have electronic density left, or in the case of modulated structures, you can also use the devolved sections so that you see which type of modulation you have for your atom. Another option that you can do, it's transform from group subgroup or to a lower symmetry iteratively. So if you have your structure, but you think you have a lower symmetry, you can just go to a subgroup here and in the transformations, and then it will show you all the symmetry operations, and you can select which ones you'd like to bring to a lower symmetry, and you can either select here which symmetry operations you want to bring and complete subgroup, or you can click on select non-isomorphic subgroup and select which subgroup you'd like to test. And you can do it for each of them and decide later based on the results. If you have disordered structures, you can also split the disordered atoms based on the ADPs of these atoms, and then you can generate rigid bodies and refine it. This helps a lot when you don't have good enough data. So, and you still keep your molecule, or it still keeps the chemical sense. You have heard a lot about superspace theory here this week and such. So we can also, and I said at the beginning that we can also work with modulated structures. So we can either work with the commensurate cases when you can use a supercell to model your structure or your unit cell, and then in case you have an incommensurate, you can also import the incommensurate one and work with it. And we can also do the composite structures, work with composite structures when you have, in this case, two lattices, different lattices, and they coexist in your material, and they cannot be described by one common supercell. So in this case, you find out from your diffraction data, it means that you have a reciprocal unit cell from one subsystem of your composite, the unit cell, reciprocal unit cell from the second subsystem of your composite, and on the top of that you can also have the satellites from the interaction between these two subsystems. And if you have even more complicated cases when you have these composites and twins, like in this case here, that we have 4 twins and the composite structure, you can add all this information to JANA, and you can add there which is the matrix correlating the two subsystems here. You can add the twin domains here, how many twins you'd like to work with, and you can solve your structure and refine your model taking into account all this information. Another option that helps a lot, it's here, the Run Reciprocal Space Viewer, because then you can visualize how the diffraction pattern of your model looks like with the information that you are considering here. For that, you can use the observed intensities, calculated intensities, and so on. So you can select what you want to see here, the direction you want to see, which layer you want to check, and compare with your experimental data and see if it agrees. For modulated structures, we can work then with the superspace approach. You will add your data, you have here the modulation vectors, and then you define the symmetry using the modulation vectors here. As I said, for the refinement, each of these parameters have a unique name, and we can refine them. So also for the modulated structures, you will have a possibility to have the occupancy, position, or the ADP parameters modulated. So each of these parameters, you will find when you open the define atomic parameters for your atom that is modulated, you can go to modulation parameters here and check which parameters you would like to refine, and then check in the Fourier map and see if it agrees well. So for instance, here you have one of the atoms, and when we do the Wolf maps for some atom, you can then see here the curve describing the modulation, or the wave describing the modulation, and the Fourier map, and you can see if this curve is describing it well or not, and then you can modify it. Yeah, it's possible to use harmonic, sawtooth, Crenel functions to model these waves. And you can also run a video in the Fourier map to see how these waves change in 3D, because sometimes you see, if you see just the map, 2D map here, you don't see completely the description of your waves. So you can also run a map, or just check in other directions, and so that you can describe it better. And now, also in the newest version, you can, in JANA Draw, when you have your model, you can also add the electronic density calculated from the Fourier maps, and you can also see the modulation directly on the image. And then if you can click on these densities, and you can add atoms or the modulation functions directly from the image itself, which is very, very convenient. Well, once you have your structure finished, modeled, then you can run the Fourier map or the difference Fourier to see if you still have some electronic density left. You can also run here the distance calculations, and with all this information, you can prepare the sieve. And it's expected that once you're finished with the sieve, you will deposit it in a database, and then in the case of the modulated structure, deposit it to Bilbao Crystallographic server, to the database for magnetic structures. And when you want to present this data, there are, let's say, nicer ways how to show it. So you can either present a Fourier map as a movie, or in the case you want to show the model itself, you can use JANA Draw to show also a movie of your structure. So in this case here, you see the modulation, or here you see it's a composite, also modulated and commensurately modulated. But if you need to just make the image, instead of showing just the average structure, you would prefer to use the final result with all the modulations included, just using more unit cells. You can see here that if you show just the average structure, it doesn't make chemical sense because the atoms are way too close to each other. But then when you add everything, all the modulations, then it makes chemical sense and you have nicer results. So, in conclusion, if you have a very simple structure, you can finish it in 5 minutes and super simple, easy. But if you have a more complicated one, you have many options then in JANA. The new version, JANA 2020, with JANA Draw, helps a lot to analyze the structures, especially because it's very interactive, so you can select atoms in JANA Draw and change atomic parameters or refinement parameters directly from JANA Draw. We can work with up to 3+3 D modulated structures with composite structures, twins, and so on. You can also run the Fourier maps, the Wolf sections, and such. And we have every year several hands-on workshops in Prague. So if you'd like to join us, it's usually a 2-day workshop. And you can just send an email to Michal Dušek, and he will subscribe you. And as I said, it's for free. The workshop is not paid. I have here some references if somebody would like to read more about these things. Also in the JANA website, you have some documentation for JANA. Unfortunately or fortunately, Václav Pedriček, he changes the software much faster than we can update the JANA, the tutorial, not the tutorial, but the manual. So we are not able to have the manual updated, but the cookbook is very updated. So, for instance, for every workshop, we have new versions of the examples, and there you can find the newest developments in this program. I'd like to thank you all for the attention, and I did this part with the normal structures, and my colleague Margarida will continue now with the magnetic options in JANA.
Thank you very much. So now the lecture is open to comments and the questions.
Yeah, I really enjoyed the animation of the Fourier maps and the structures. I'm curious, can you export those videos as like MP4, something like that?
Yes, you can export all these videos. Yeah.
Nice. Nice.
Also from the composites and such, from this modulated, the model as well, you can export it.
And can you, the program is only supported in Windows, no? That's it.
By Windows? Yes, only for Windows now.
Only for Windows.
Yes.
Is there any plan to make...
I don't think so, because Václav, he wants to improve more for the magnetic part. So and there are always more difficult cases for him to solve. So I don't think he will improve it or develop other versions for Linux and such. And I think the last version for Linux and the Mac was 2006, I believe. But like some really older version.
Other questions? Comments?
Well, yes, there's some question over there. One thing that I'd like to add, for us users, I'm actually very glad that you have these people developing these softwares, right? And unfortunately, there are not so many people interested in programming anymore. So in Václav's case, he's the only one programming JANA. And yes, in some cases here, it's very few people programming. So it is interesting as well if we would have more people helping programming this. And to continue later with these tools that we can use. Otherwise, we will not have it for so long.
Thank you. I got one question about some explanation about very important factors shown on the several pens, especially when you do the data introduction into the software, and there are several steps for the determination of the point group, and afterwards is the space group, and there are some indices that the user can use to tell whether the selective point group or space group is the best one or not. And I have noticed there are some detailed explanations of each factor on the what is that? The tutorial, the file, the cookbook. But I want to ask: is there any like a systematic explanation of all these parameters?
Yes, yeah. So
and where can we find it?
Yeah, so the manual, there are 2 manuals in the website, or I also have them with me, so if you want I can give you. Manual from 98 and 2000, they have, if not all, most of those parameters explained and with references to which equation he used from where and so on. So things behind this version now, it's the same as in the previous versions. So we have in the manual exactly how it works and which parameters means what and so on. Yeah, so it's there. Yeah, otherwise in the references, because then it sits there, there is the citation for it, the reference, so you can also check the reference and there will be the explanation on how it works and so on. So for instance, for the extinction parameters, you have several options there, several models to use. So I added here, yes, here for instance, extinctions. And then when you go to this article, you will have the equations and exactly what Václav used to implement in the program. Yeah.
Okay, thank you.
He means the factors when we import data. I think he means what are
the R factors and such, yes, this is in the manual as well. The manual from 98 or 2000. Well, you have the presentation online, so you can just check it there.
Other question or comments? Okay, if not, let's thank Cinthia again. Thank you very much.